So coming to chemical equilibria, we have Le Chatelier's principle. Do you have an idea about Le Chatelier principle? Do you have any idea on this Le Chatelier principle? So see here, I have a vessel like this, U-shaped vessel. Okay. So see, this is the ball initially placed here. Okay, this is the ball initially placed here. This ball is in rest position. Now it is here. If I am going to disturb this ball placed like this side, then after 2-3 minutes, this ball becomes into its original position. Right? If I am going to disturb this ball into this side, again this ball becomes into its original position here only. If we are going to move like this, then this ball becomes same position. Okay. Otherwise, you can take one more example. I have two chambers which are having some amount of liquid in this chamber. Don't make noise. So see here, I have chamber A, chamber B. In this chamber A, I have 10 liters of liquid. In this chamber B, 10 liters of liquid. Then only we are going to say these two are in equilibrium. How much liquid is present in A? That is equals to liquid present in B. So these two chambers are in equilibrium. So my intention, I am going to add some amount of liquid to the chamber A. Okay. So for this case, whenever I am going to add additional liquid or whenever I want to change that equilibrium, then this system opposes the change in equilibrium. Suppose if I am going to add 2 liters of H2O to the chamber A. Okay. I wanted to disturb the system. So what can I do here? I am going to disturb the system by adding 2 liters of water to the chamber A. But this system opposes the changeness. How it opposes the changeness? Here 1 liter is going to add this chamber A and 1 more liter is going to add to the chamber B. That means whenever we are going to add this 2 liters to the chamber A, 1 liter is losing from the chamber A automatically. Whenever we are going to add simultaneously, 1 liter is going to add in chamber B. That means whatever the change we are going to initiate here, that change is opposed by the system. That principle discussed by Le Chatelier. That principle is called as Le Chatelier principle. So what we can say simply, whenever the system is in equilibrium, if we are going to disturb the system, that system never allows the changeness. That means the system opposes the change in equilibrium of the system. Okay, that principle said by Le Chatelier. So how we are going to write this definition for this Le Chatelier principle? So see here, when we change the concentration, or pressure or temperature, or next one, adding of an inert gas. Do you know inert gas? adding of an inert gas to the reaction system, reaction at are mentioned here reversible reaction, to the reversible reaction. What it mean? Reversible means how much reaction going forward direction is there, same rate of reaction is going to backward direction. That is reversible reaction. So here reversible reaction at equilibrium. At equilibrium, then position of equilibrium shift towards such a direction that changeness is nullified. So this is the definition for Le Chatelier principle. See here, when I am going to disturb the system by increasing the concentration or decreasing the concentration, increasing the pressure or decreasing the pressure, if we are going to discuss about pressure, then volume is also affected. So volume is also included for the factor. Next, if we are going to increase the temperature or if we are going to decrease the temperature, if we are going to add that inert gas to the system, or if we are going to add the catalyst to the system. So these are the factors which are going to affect on a system which is in equilibrium. Okay, but system never allows the changeness in equilibrium. Clear? So that principle is discussed by Le Chatelier. Okay, so first we are going to discuss one by one what are the factors affecting on equilibrium system. So first one I am going to discuss concentration. Okay, so for this concentration, see here, I have a reaction. Do you know the formation of ammonia? So see here, this is the ammonia reaction. So in this reaction, nitrogen reacts with hydrogen, then formation of ammonia will takes place, right? So what is my intention here? The system is in equilibrium. Whatever that forward reaction is there, that is equals to backward direction. Okay, forward reaction is equals to backward reaction, or reaction towards forward, how much rate is there, that is equals to backward rate of reaction. Clear? So that is reversible reaction. In this concept, first we are going to discuss about concentration, right? So for this concentration, if I am going to decrease the concentration of reactants, what are the reactants we have here? What are the reactants we have in this reaction? Nitrogen and hydrogen. These are reactants, right? So if I am going to decrease the concentration of nitrogen, otherwise you can consider like this, reactants are products P. Okay, so see here, I am going to increase the concentration of reactants. I am going to increase the concentration of reactants, then reaction shift towards which direction? Forward direction. Okay, if we are going to, if initially the system which is in equilibrium, if we are going to increase the concentration of the reactants, then system moves forward direction. Then if I am going to decrease the concentration of reactants, then system moves which direction? Backward direction. Okay, same thing if I am going to increase the concentration of products, here I am going to increase the concentration of products, then automatically reactants concentration will decrease, then system moves backward direction, then that will becomes in equilibrium again, right? Clear? So if I am going to increase the concentration of products, then reaction shift towards which direction? Backward direction. If I am going to increase the concentration, sorry, decrease the concentration of products, reaction shift towards right. Then tell me, apply these 3 4 concept 4 here. If I am going to increase the concentration of ammonia, then what happened? If I am going to increase the concentration of ammonia, reaction shift towards, I am increasing the concentration of ammonia. Which type of reaction? If I am going to increase the concentration of hydrogen, I am going to increase the concentration of hydrogen. Forward reaction, right? If I am going to increase the concentration of nitrogen, which type of forward reaction, right? That means reaction shift towards forward to equilibrium, to get that equilibrium. If I am going to decrease the concentration of ammonia, here I am decreasing the concentration of ammonia, then equilibrium shift towards forward direction. Is that clear for all of you? Right? So please listen, try to understood this point. Very simple concentration. Whenever we are going to disturb the system by applying the concentration, either increasing or decreasing, either concentration of reactants or concentration of products. If we are going to discuss about reactants, if I am going to increase the concentration of reactants, then reaction shift towards forward. Why? Because of to get that equilibrium. So that will increase the yield of products. Are you getting my point? I want to prepare ammonia, more yield of ammonia. So I have nitrogen and hydrogen. Initially the reaction is in equilibrium. So now I want to increase the yield of ammonia. Then what can I do? Either I am going to increase the concentration of nitrogen or increase the concentration of hydrogen. That will yields more amount of ammonia, right? More yield of ammonia. If one more thing, if I am going to decrease the ammonia, if I want to decrease the amount of ammonia, then what can I do? I want to decrease the yield of ammonia. Then what can I do here? Decrease the concentration of nitrogen or hydrogen. So that will shift the equilibrium towards backward. That means decomposition of ammonia will take place, but ammonia formation doesn't take place. Clear? Is that clear for everyone? If you have any doubt, then you can ask. Clear? Very simple one. If we are going to increase the reactants concentration, reaction moves forward direction. If we are going to increase the concentration of products, reaction move backward direction. Clear? So this is about concentration which is affecting on equilibrium of an system which is already in equilibrium. Clear? So definitely if we are going to increase the concentration, that will opposes the change in equilibrium. So next one, what we have next one? Pressure. So for this pressure, all of you aware about Boyle's law, right? What is Boyle's law? Tell me. The mass, the volume of a given mass of gas is indirectly proportional to the pressure of the gas at constant temperature. That is Boyle's law, right? All are forgot? At constant temperature, which law? What about Avogadro's law? I'm asking Avogadro's law. So see here. The volume of given mass of gas is directly proportional to the number of moles of gas which is present in a liquid or container. So that is at constant pressure and temperature. This is Avogadro's law. So as we know these two relationships, right? Avogadro's law and Boyle's law. So from this one, I have three reactions. Please concentrate here. Concentration effect is very simple one, but I think this pressure is some difficult. Why? Because here we are going to calculate first number of moles. Do you know that delta N Kp is equal to Kc delta nRT, right? That is the relationship. So we are going to apply that delta N part only. So don't confuse with the equation. See here, I am going to write one reaction here. First I have hydrogen reacts with I2, then formation of 2HI. All are gaseous products, all are gaseous, reactants also gaseous. Next reaction, PCl5 decomposes into PCl3 plus Cl2. Here also gas. Next reaction, don't make noise. Nitrogen reacts with hydrogen, then formation of ammonia will take place. So see these three conditions, don't make noise. Okay, so see what I said just now, delta N plays major role here. We are going to discuss based on this delta N value only what the changes are done by the increasing the pressure or decreasing the pressure in a equilibrium system. So see here, in this reaction, first reaction, hydrogen is reacting with iodine, then formation of hydrogen iodide takes place, right? So what can I do here? I am going to increase the pressure of the reactants. Listen properly. I am going to increase the pressure of the reactants. Pressure. We are not discussing about concentration. We are discussing about pressure. So if I am going to increase the concentration of, if I am going to increase the pressure of these reactants, then reaction does not affect on this equilibrium. There is no such effect on equilibrium. Why? Because whatever the number of reactants are there, number of moles of reactants are equals to number of moles of products here. So see here, how we are going to calculate delta N, delta Ng. If we have here gaseous moles, then we are going to consider this as Ng. Okay. So for this one, products minus reactants. So here Np minus Nr to calculate the number of moles difference. Okay. So tell me how many? Here 2, here 2. How we are going to consider that is 2? Here 1 mole of hydrogen, 1 mole of iodine. Here 2 moles of hydrogen iodide. So total here 2, here 2. Then delta N value becomes 0. If delta N value becomes 0, then if I am going to increase the pressure or if I am going to decrease the pressure, there is no change in equilibrium of the system. Okay. Why? Because there is no such difference is there in the number of moles. So reaction still in equilibrium if you are going to increase or decrease the pressure of the system or reactants or products. Clear? Is that clear for everyone? They are simply asking if we are going to write that reactions for theory purpose, then you can remember these reactions also. In JEE, in MCQ types, they are providing the reaction, but you should know aware about how to calculate the difference of number of moles, delta N. Then they are going to ask this reaction. If pressure is increasing, then what happen? Okay, without knowing this calculation part of delta N, then you can unable to answer to this question by increasing the pressure or decreasing the pressure. Clear? So this is for first reaction. Then coming to next reaction, what is the reaction? PCl5 can decompose into PCl3 and Cl2. So see here, how to calculate the number of moles. How many number of moles here? Here. So what is the difference? Here delta N is 1 means we are getting delta N value as positive, right? So in this case, if I am going to increase the pressure, listen, if I am going to increase the pressure of the system or pressure of this reactants here, then indirectly what happened to volume? Decreases. If we are going to increase the pressure of the system, then what happened to volume? Decreases. Why? Because those are indirectly proportional. Clear? Then how we are going to decide whether the reaction is forward or backward? So see here, volume is decreasing. Volume is directly proportional to, according to Avogadro law, volume is directly proportional to, then where we have number of moles are more, and then reaction shift towards number of moles where the number of moles is less. So reactant side will shift. That means it shift towards by increasing pressure. Are you getting clarity on this one? So if whenever we are going to discuss about delta N value is positive for that type of reactions, if we are going to increase the pressure of the reaction, then automatically volume is going to decrease. Volume is going to decrease means where that number of moles are less, reaction shift towards that side. Clear? So you can blindly remember that if we are going to increase the pressure, then reaction shift towards where the number of moles of reaction is less. Clear? Here we have less number of moles, so reaction shift towards backward direction. Clear? Clear on this first point. If I am going to decrease the pressure, this is indirectly volume is decreasing. Here volume is increasing. So here this means if volume is decreasing means number of moles are decreasing. Here number of moles are increasing. In this case reaction shift towards backward. In this case reaction shift towards forward. Right? Any doubt? So coming to next one, tell me this one. Delta N is equal to how much? 2. Then how much? So delta N value we are getting as negative. Right? So in this case, if I am going to increase the pressure of the system, then what happen? Indirectly, volume is going to decrease, then number of moles decrease. Then tell me now, reaction shift towards where we have less number of moles. So reaction shift towards forward direction on product side, or it shift towards forward direction. Okay. Blindly you can remember, if we are going to increase the pressure of the system, then system is opposes the changeness in equilibrium, that shift towards where the number of moles are less. Whenever we are going to discuss about pressure, but this is opposite to this concentration. Okay, don't mix up with concentration and pressure. Clear? If I am going to decrease the concentration of pressure, then what happened to volume? Volume is increasing, then number of moles also increasing, then reaction shift towards backward direction. Clear? Is that clear for everyone? Right? So one more thing here, you can apply this part also. We are mentioned here pressure. There is one more possibility is there. Instead of pressure, if we are going to discuss about volume, then these all words are becomes opposite. If we are going to increase the temperature, volume, then what happen? Right? So reaction shift towards. Are you getting my point? No? See here. Here we are discussing based on pressure. Right? If we are going to discuss based on volume, remove this pressure. I am increasing the volume. Then what happened to reaction? Which direction? Forward only. Here we are decreasing the pressure. That means indirectly we are increasing the volume of the reaction, right? Volume of the reactants. Then reaction shift towards forward. Then why are you confusing? I am just asking here. I am instead of taking pressure, if I am going to discuss about volume. So here I am not going to discuss about pressure. So you can remove this pressure term. I am indirectly increase the volume here. Instead of taking pressure, I am directly discussing about if I am going to increase the volume, then what happen? Number of moles are increasing. So if number of moles are increasing, reaction towards forward. Clear? Same for all. Is that clear now? Shall we go to next one? Which one? Next one. Temperature. So see here. For this temperature case, I have one reaction. Nitrogen reacts with hydrogen. Sir, why are you taking for every time this reaction only, right? Why? Because for the explanation part, this reaction is very easy to explain and you people also easy to get the clarity on this chatelier principle. So see here, this is the reaction. So tell me, what do you understood by this, seeing this reaction? Nitrogen reacts with hydrogen, then formation of ammonia. Along with that, delta H is equal minus 93 kilojoules. What it means? What it means? Which type of reaction, sir? It is an exothermic reaction, right? So this reaction, formation of ammonia, is a exothermic reaction. So what is our concept? Temperature, right? So see here, if I am going to increase the temperature of this reaction, which is in equilibrium, already this is an exothermic reaction. If I am going to increase the temperature of the reaction, which is an exothermic, then reaction shift towards backward or forward? Backward. Why? Because here already the temperature is more, right? Reaction shift towards backward. So what is the reason? Already what is the formation of ammonia is there, that reaction is there, that reaction exothermic. Exothermic means already heat is evolving. We have more heat here. Okay, for example, so all are aware about car, right? Vehicles. So especially cars and four-wheelers. Along with that engine, we have coolant, right? So in that coolant, what is the main essential purpose of coolant? To cool that engine, right? So while engine is on, then that will increase the temperature of the engine. If we are going to give that heat water, then what happened to engine? That will increase the engine temperature, then collapse, right? So main intention to coolant is the decrease the temperature. So same thing you can apply here. Already heat is more, temperature is more. If we are going to increase the temperature again, then here reaction may go blast the reactor. Okay, we are going to conduct reactions on by using reactors, very big reactors, right? So in that case, already exothermic reaction is going on, right? So heat is producing. If I'm going to increase the temperature, then heat may going to increase, but reaction opposes the changeness, right? So that is the reason to shift backward, and there here temperature is going to decrease. Clear? Is that clear for everyone? Nihal, clear? I think you are not understood this point. Here I am going to increase the temperature, but here we already have more temperature. So by utilizing this much temperature, reaction shift to backward direction. That means decomposition of ammonia will take place. For the formation of ammonia, there is no heat required. Why? Because this is already exothermic reaction. But for the decomposition of ammonia, it will require how much energy? 93 kilojoules, right? If we are going to discuss about forward reaction, that is exothermic. If we are going to discuss about backward reaction, that becomes endothermic. Endothermic means we are going to give some amount of energy to the system, right? So that type of reaction is takes place. So how we are going to decide here? Whenever we are going to perform and reaction which is already exothermic reaction, for those cases, if we are going to increase the temperature, then reaction shift towards backward direction. If temperature is, if we are going to decrease the temperature, then reaction goes. One more thing, this is about exothermic reaction, right? If we are going to discuss about endothermic reaction, that means delta H is equal positive kilojoules, right? So for this case, right? So for this case, for endothermic reactions, if I am going to increase the temperature, then what happened to reaction? Reaction shift towards forward only. Why? Because it needs some amount of temperature, right? I am giving the temperature, then reaction shift towards forward direction. If I am going to decrease the temperature, then reaction shift towards clear. Is the temperature effect is clear? So see here, simply don't confuse with this temperature, pressure, concentration terms. Okay. If we are going to discuss about exothermic reaction, exo means heat is already evolved or released, right? If I am going to increase the temperature, then again already we have more temperature, that will increase the temperature of the reaction may collapse, right? So that is the main reason reaction shift to backward direction where the temperature is low. That means to perform a exothermic reaction, low temperature is favorable condition. Okay, write that point here. Low temperature is favorable for which reaction? Exothermic reaction. Then what about high temperature? High temperature favorable for endothermic reaction. One more thing here, you can remember here, low temperature is favorable for exothermic reaction. The reaction shift towards where the temperature is less. Okay, clear? That means reaction shift towards backward in this case, ammonia case. Here, forward for endothermic. Clear? This is about temperature. Next we have, next one, addition of inert gas, right? Addition of, okay. So next one, addition of inert gas. See here. Don't make noise. Listen. Simple one. For this addition of inert gas, what are the inert gases we have? Tell me. Helium, neon, argon, krypton, xenon, radon, OG, argon. You can remember up to here. Helium, neon, argon, krypton, xenon, radon. These all are inert gases. Any other name for these gases? Any other name? Zero group elements. Right? So see here. So for this addition of inert gas, we have two conditions. So first condition, addition of inert gas at constant volume. So see here, addition of inert gas at constant volume. Okay, listen. Addition of inert gas at constant volume. Next one, addition of inert gas at constant pressure. So see here, we are discussing about gas, right? So see here, I have two chambers. That means one is, for example, in constant volume. In this case, listen, if I am going to add some inert gas, whatever it may be, if I am going to add inert gas to this chamber, then what happen? Its volume is constant, right? Are you getting my point now? I have that bottle. In that bottle, initially that bottle is having 1 liter water only. There is such possibilities there to fill that up to 2 liters. If I am going to add that water 1 more liter to that bottle, then what happen? That water volume becomes 2 liters, right? 1 liter initially there. If I am going to add 1 more liter, then that becomes 2 liters, right? Listen, Supratik. Inside the bottle, I have some amount of gas. I am going to add some more amount of gas to the same container or same bottle. Then what happen? Inside the bottle, pressure is going to increase, but volume doesn't change. Why? Because whatever that bottle volume is there, definitely that gas going to occupies total amount of volume of bottle. Are you getting my point now? So same thing you can apply here. Don't see here. I have the chamber or container here. Inside the container, I have some amount of gas. Now I am going to add some amount of gas, inert gas to this one. So we are discussing about constant volume, right? Here volume does not going to change, just pressure is going to change. So in that case, there is no such effect on this equilibrium of the system. Clear? There is no effect or no changeness is there in the case of whenever we are going to discuss about volume at constant volume. At constant volume, if we are going to add inert gas to the system, there is no such effect is observed. Clear? Whenever we are going to discuss about constant pressure, so tell me what is the relation? What is the relation? Pressure is inversely proportional to at constant. So here, this is the gas. Okay, this is the gas. So in this gas, if I am going to increase the volume, pressure is constant, right? Okay, pressure is constant. If we are going to discuss about 1 atm pressure is there in this container, by adding inert gas, by adding some amount of inert gas to the system, then what happened to this pressure? Pressure becomes constant only, but volume is going to change. Initially the volume is up to here, right? Gas only, right? Then what happened to next? If adding that inert gas, its volume becomes increasing. Clear? So that will affect on number of moles. Clear? So now tell me, if I'm going to increase the, if I'm going to add that inert gas, then indirectly volume is increasing. Where the number of moles are more, then reaction shift towards. Clear? Whatever the points we are discussed in this one, see here. If volume is increasing, then reaction shift towards. Why? Because number of moles are. Clear? So same thing, you can apply those points here. Clear for all of you, Traya? Clear? Right? So this is about addition of inert gas. Right? So next one, catalyst. So see here, the system which is in equilibrium, for that case, if we are going to add that catalyst, then catalyst doesn't affect on equilibrium of the system. See here, nitrogen, hydrogen, then formation of ammonia will take place. So for this one, we are going to use the catalyst as Fe. Fe means iron, right? So this iron doesn't affect on equilibrium of the system. Okay, but it doesn't affect on equilibrium of the system. You can observe here, please don't make noise. So see here, I have reactants. This is products. Okay, see here, don't make noise. So see here, this is without catalyst. This is with catalyst. So in these two cases, you can observe here, this is the activation energy. First activation energy, E1, this is E2. So see here, for this case, whenever we are going to discuss about equilibrium, system which is in equilibrium, for that system, if I am going to add catalyst, then what happened, right? Equilibrium doesn't change between the system of reactants and products, but what here changes is we are going to observe, initially whatever that activation energy is there, activation energy is nothing but here, if we are going to conduct a reaction, 1 hour takes place to get that formation of products. If I am going to add some amount of catalyst to that reaction, then reaction may complete to formation of products in within 30 minutes. That means time is reducing. Indirectly, time is reducing means rate of reaction is increasing. So that is happened here. Initially, this rate of reaction or activation energy is more. But whenever we are going to add catalyst to this system, to the reactants, then its activation energy is decreasing. Activation energy is decreasing means rate of reaction is increasing. So this is the effect of catalyst on equilibrium system. But not any changes is observed on the equilibrium of the system. Just we are going to observe whether that reaction is forward, whether that reaction is fast or slow. That means indirectly activation energy is mainly effect on this equilibrium. Clear? So these are 5 factors which are influenced by the equilibrium according to Le Chatelier's principle. Clear? Is that clear for everyone? Any doubt? Clear? Right? Okay, thank you. Shall we